Bismillahirrahmanirrahim. Assalamualaikum. So after view a few video from me, I believe all of you understand a little bit how to use every instruction that have been discussed before. So it's time now for us to look into a few example how to use this instruction to solve a real problem. So in this video, I try to discuss three arithmetic problem. Yeah? Our first problem is x is equal to 2 plus 5, whereby x represent address 2000, meaning that the data, the result from this addition process will be stored at this address. Okay. And the size for the result is only limited to 16 bit, not 32 bit. Okay. So to solve this problem, first thing first that we need to do is to create our flowchart. Since the program is worked by flow, one by one, and then we need to develop our flowchart. Every flowchart have to start with start or begin or mula. Okay. Next must follow by initialize or initialization. Here we write every information that is important for us in uh, in solving our problem. Like this one, I write that for x, the address for x is held by R0. Value 2 will be stored inside register R1. Value 5 will be stored inside register R2. Okay, after I copy all this value to the each of this register, and then I start to do the addition process. And the addition process is involved 2 plus 5, which is R1 plus R2. Next, after finish do this process, I need to transfer the results to X. So I write here store result into X. And for every flowchart, we must close our flowchart with N or tamat. Okay. After finish with our flowchart, we need to transfer each process into a coding, into the assembly coding for ARM. And if our processor we use let's say Motorola, this coding here will be different. Okay. First, for start, we need to start our coding with N3, and for close we need to end our coding with END. Okay. Initialization. I load the value 2000 into R0, meaning that R0 now hold the address for X, address to represent X. And then I move value, I use instruction move, value 2 into R1 and value 5 into R2, as per stated in this flowchart. Here I can use move instruction because the immediate value is only 2. Here, if you still remember, the immediate value must not exceed 255 in a decimal value. Okay, so now since the value is only 2 and 5, I can use instruction move as. Next, for addition process, I use instruction adds R1 R2, and to store I use instruction str h, because the size of the data that I want to move into R is only 16 bit, and if the size is 32 bit, and then I just write str without h. Okay, so the value inside R1 will be sent to the address held by R0, which is R0 whole address 2000,000 to represent X. So now we go to our Kill IDE software and then just copy this program and paste here. Okay, and you notice that entry and n, there is no entry and n here. Why? Because in one program we must only have one entry and one n. Here this is the entry. Okay, and down here you can see n here. You cannot use more than one entry or n. Okay, with our program here. So after we finish write our coding, as usual, we must build a file to here to make sure that our coding is free from error. Yes, without error, zero error, and then ready for debug. Okay, first step, we send or we put to value 2000,000 into R0 to hold address for X, and then move 2 to R1 and 5 to R2. Okay, here 2 and 5, and next we can start with adding process. R1 add with R2, and then the result is update into R1. See, 2 plus 5 is 7. The result is 7. So the 7 will appear in R1. So this result we want to store to address 2000. Address 2000 now hold by register R0. So 2000 here, 2000 for one half word, the result will be stored here. 1, 2, 3. See, 0007 in the form of little endian, little endian form. Okay, so finish with example number 1. Next, we look into example number 2. Example number 2, x is equal to 2 plus b, meaning that I want to add immediate value of 2 with a value that is available at address 00000050. Okay, and the size of the data at this address is also 16-bit. Okay, so to solve this problem, we need to modify our flowchart like this. What is the difference between the previous flowchart? Here, before this R2, I load with immediate value of 5, but now for R2, I load with value from address 50, and the rest R1 I plus with value B or R2, value inside R2, and store result, finish. So I need to modify the coding according to the flowchart. Start with entry. I load the address for X into R0, and then I move immediate value of 2, here this value 2, into R1, and then I load a value from address 50. Sorry, there's no 2000 here. Value 50 into R2. Okay, and then I add R1 with R2. Okay, and then store result. Okay, let's go to kill. Try to modify our coding. 2000 R1 and 2. 50, LDR50. Here we must use LDR, LDR R7 with 0x 00 00 00 50. Load, and then LDRH. Why H? Because we only want to load a 16-bit. Okay, we load to R, register R2. R2 indirect addressing mode for R7. Okay, next I add with R1 and R2. 50. Okay. Okay, before this, we only use one line of instruction because I only move R2. Okay, immediate value. But this time, we want to move data from memory address. That's why we need to use at least 2 instructions. Okay, so we're ready. We must rebuild our file. Okay, rebuild our file. Okay, error free. So go to a debug, and then okay, we run. We load address 2000 to R0. We move immediate value of 2 to R1, and then we load a value from address 50. 50, we go to address 50. 10, 20, 20, 30, 40, 50. Meaning that we want to load data 0211. 0211 to 0211 to R2. Okay, 0211 into R2. Okay, R7 hold the address, R2 hold the data. Data for B. This is B. Okay, and then we start the adding process. R1 with R2. Okay, what's the value? R1 is 2. Our result will be 213. Okay, 213 now appear at R1, and then we store this result to R0 to address 2000. Why? Because the question asks us to store the result into X, which is X represent address 2000. So let's go to here, 2000. Okay, the result supposed to appear here. So 1, 2, 3. Yes, 0213 in the form of little endian. Okay, finish with example number 2, and then we go to example number 3. Example number 3. For example number 3, I use 3 variables, a plus b minus c. Okay, to make it easier for us to write our coding, I put a plus b inside the bracket. So which is X still represent address 2000, 8 40, B address 50, C address 60, and the size is still 16-bit. So I do the modification for my flowchart. It will appear like this. But for the operation, one operation for add and another one operation for subtract. Okay, here because we got two arithmetic operation here. Okay, and the rest is similar with our previous example. Load R0 whole address for X, R1 whole data, not address, not only address, whole data for A. So address hold by R7 and then copy data to R1, Here, address hold by R7, address for B hold by R7, and then data for B is copied to R2, and next address for C is hold by R7, and then data for C copy into R3. Proceed with the addition process. So for this one, I just want to copy and paste to my kill here. We stop our debug, and then we copy here. We need to align. Okay, remember to align our mnemonic to prevent error. So for this one, you can put any comment if you like. Here, started with a semicolon. This is address for X and apa? No, start with semicolon. A address A add for A tap data for A. Okay, enough. We build a file. Oh, where's comma? Missing comma. Here. R0, comma, LDR, yes, yeah, another comma, here. Okay, rebuild our file. Yes, zero error, run bug. Okay, first R0 whole address for X, here, and then R7 whole address for A, data for A into R1, R7 address for B, data for B into R, data for B into R2. Wait. LDRH R7. Oh god, I did a mistake here. So I need to correct mistake first, sorry. It's not 2000, it's 0. Okay, rebuild our file. Rerun the debug. Ready? Okay, again. Whole address for A, whole data R1, whole data for A, R7, whole address for B, R2, whole data for B, R7, whole address for C, R3, whole data for C. And then we add R1 with R2. R1 207 plus 217. And remember guys, this value is always in hexa form, so please don't confuse. Okay, 4 1 7 plus 7 is 14 in decimal, but in hexa form, what is 14? D, I think D. So we add tab 4E, sorry, 41E. This is the result of the addition. And then my god, I forgot to put subtraction. Okay, sorry. Here, I forgot to copy this. Subtract. I see the mistake. Add. Subtract R1, R3, so we need to repeat our file. Debug. So we just speed up our process. Okay. 422. This time it's result 422. I subtract R1 with R4. R1 is 422. R4 0. So the result must be 422 minus 0, and the result will be 422. Yeah, 422, and then we store this result to R0, and R0, remember, whole address for X. 1 2 3 here, 0 4 2 2.